Hello class, welcome to the next segment in the week 3 material, and in this segment we're going to take a look at another example of a while loop and also give you a chance to sort of check your understanding to make sure you understand what exactly is going on here as it pertains to while loops. So here I've got a program that we will take a look at in a little bit. You'll actually see what that actually does in Spider. But for now, I want you to sort of take a look at this program and also fill out the table or some sort of table that we had in the previous segment, where we had the cycle number, we had the value of x before a cycle, the value of x after a run through the loop, and then also the column to check if the condition in the loop is satisfied. So I'll give you a few minutes to pause the video and attempt that exercise on your own, and then once you've done that, then unpause the video, and then we can check to see if what you have is in fact correct. So I'll give you a few seconds to do that. So hopefully the table that you got is going to more or less resemble what we see on the screen here. And then once I show you the table on the screen, then we'll go into Spider and see if this program actually does what we expect it to. So filling out this table, so again, column number for a column for the cycle number, a column for the value of x before we go through a cycle of the loop, the value of x after we go through a cycle of the loop, and then again checking if this condition in the while loop is in fact true. So first time through the loop, x is defined as 50 beforehand, so before we even start running through the indented statements, x is again assumed a value of 50. And if we, so and also something we should check here is if 50 modulo 7 is greater than 0, because if that's not the case, then the while loop won't run at all. So 50 modulo 0 is in fact 1. 1 is greater than 0, so we start running through the loop. So now we run through the loop, which involves increase the value of x by 1. That's what this statement here accomplishes. So x will go from 50 to 51, and then now we check to see if that condition is in fact true. We ask if 50 modulo 7 is in fact greater than 0. 51 modulo 7 is in fact 2. 2 is greater than 0, so that condition is met, meaning we continue running through the while loop. And that means we go through it another cycle. So the second time through the loop, again, the beginning value for x is just what we had left over at the end of the previous cycle. So that is just simply 51. We add 1 to x again, which is 52. Now we ask this question, 52 modulo 7, is that greater than 0? 52 modulo 7 is 3. 3 is greater than 0. That condition is met, so we continue running through the loop. And then we go to the third time through the loop, the third cycle, and the beginning value for this cycle is just what we ended with on the previous cycle, which is 52. We add 1 to x again to get 53, and we check this condition, 53 modulo 7, is that greater than 0? 53 modulo 7 gives us a result of 4, since that's a remainder term in this division. 4 is greater than 0, so the condition is satisfied, therefore the loop will continue running. Then we go to cycle number 4, the fourth time through the loop, and again, the value of x before we go through this cycle is just the value of x that we had left over at the end of the previous cycle, so this is 53. And after that cycle is complete, x will then become 54. Again, just simply adding 1 to the value of x. And again, we ask this question, 54 modulo 7, is that greater than 0? In this case, this gives us a remainder term of 5. 5 is greater than 0, so the condition is met, so the loop continues onward. So now we go to cycle number 5. And again, we just simply carry over the value that we had at the end of the previous cycle, and we add 1 to x again to get 55. And again, we check this condition, 55 modulo 7, is that greater than 0? And 55 modulo 7 will give us a result of 6. 6 is greater than 0. The condition is met, so the loop continues onward. And through this, if we go to the sixth cycle now, x is still 55, the value that we had left over from the end of the previous cycle. Now we add 1 to x again to get 56. Now we ask this question again, 56 modulo 7. Now we get a remainder term of 0 from this modulus operation, and 0 is not greater than 0. So that means that condition is not met, which means the loop terminates. And since this loop is now finished, the program is, or the computer is then free to run whatever appears after that, which means after it's done with this loop, then it's going to proceed onward to print out what the value of x is. And just by the deduction in this table here, if this is in fact doing what we expect it to do, then the final value, or the final value of x that breaks the loop, will be 56, which should be the value that we see in the console if we run this print statement here. So let's try to get some verification and see if that is in fact what we get what we get in the end. So if we run this program, we can see we do in fact get the number 56 appearing in the console here. So essentially what this program does is it takes some starting value and finds what the next multiple of 7 is. So again, that was just more of an exercise to sort of check your understanding, make sure you understand how while loops work. And this is also a great review of the modulus operator, greater than, and some other little tidbits that we've introduced prior. But hopefully it makes sense why exactly we get the result that we do. And that's going to do it for this segment on while loops. And in the final segment, we will talk about some specific keywords that you can use in loops, which sometimes is referred to as loop control. So with that, I will see you all in the next segment.